Okay, see Lindelof videos. Applying the properties of rational exponents. First off, you have to know the properties of exponents. I did it in another video. Here those rules are. I'm not going to go over them, but I'll put it up on the screen for a minute for you to take a peek at. And if you want to, you can pause the video and write these rules down because these are the properties that we're working with. And there are kind of generally 6 of them, 1 through 6 here. If you have any questions about those, please let me know. But let's go back to our video, which is how to apply these rules. And it's kind of cool. For example, here's one of the properties that we can use. We can say that the square root of a times b is equal to the square root of a times the square root of b. This isn't always real convenient, so people say, oh, I'm going to use this whenever. There has to be a reason to use it. Here's an example of where it works perfectly. The square root of 16, just as a way to prove this to you, is the same as the square root of 4 times the square root of 4. Square root of 16 is 4. Square root of 4 is 2. This multiplication sign is this one. Square root of 4 is still 2. 2 times 2 is 4, so that works. Sometimes you'll be asked to simplify something like, what's the square root of 18? Well, I don't know what the square root of 18 is, but I know that the square root of 18, I look at 18 and I'm like, okay, what factors does it have that are perfect squares? And it has one perfectly square factor, which is 9. So square root of 9 times the square root of 2. 2 times 9 is 18, so I'm just testing this rule here. Say, okay, where the square root of 18 can be simplified, the square root of 18 can be rewritten. We know the square root, the principal root of 9 is 3, and 3 times the square root of 2. So I can hear you out there like, well, what's the square root of 2? I don't know. But this is a simpler form than this. So that's one thing we can do to apply our rules. The other thing we can do is this, and if you take a look at this for a second, sometimes it makes a whole lot of sense, and sometimes it doesn't seem as obvious why you would want to do this. But here is an example. We could take, like this, we could take the cubed root of 135. And let's pretend for a second that we know that 5 times 27 is 135. So we could say, well, that's the same as the cube root of 27 times 5. Well, just looking at the rule that we just used a second ago, we could say, okay, well, that's the same as the cube root of 27 times the cube root of 5. Cube root of 27, hopefully we have that is 3, and 3 times the square root of 5. So here is a simplified version of that property. So hopefully that's helping a little bit. The other thing we might use is this. We could say this. We could say this cube root. We could take the cube root of x over y cubed. And we could use a rule that we know. First off, we could say this. We could say that this is the same, right? Because this is radicals are rational exponents, is the same as taking, so I'm going to take this right here. I'm going to say this cube root is the same as the rational exponent 1/3. So I can replace this and say is the same as this. And here, just the application of this, I can say x over y cubed. I just pick this up and put it on the inside. Now we also know that exponents are distributable over division. So I can distribute that here and here. So we can get x to the 1/3 over y to the 3rd to the 1/3. We know from the second rule of exponents that we multiply these two things, so we get x to the 1/3 over y to the 3/3. And of course, 3/3 is 1, y to the 1st, and y to the 1st can just be written this way. So we can do that. So there's all these little applications that we can use, and they really, really come in handy. So I kind of wanted to make sure that we have seen those before. Let's try to look at another one. Let's try to look at another one here. We could take, oh, you know what, before I do that, if you don't mind, can I help you with this? Because some things are not possible. The square root of x plus y is not equal to the square root of x plus the square root of y. let's look at this for a second. So we say, okay, the square root of 8 plus 8. Well, the square root of 8 plus 8 is the square root of 16, which is equal to 4, isn't it? Well, if you broke this out, you say, well, the square root of 8 plus the square root of 8 is equal to 16. Question mark. Not saying that's true. I'm saying, is that true? Well, we know that the square root of 8 is greater than 2, isn't it? So square root of 8 is greater than 2. The square root of 8 is greater than 2. A number greater than 2 plus a number greater than 2, is not equal to 4, is it? So it's a big, big deal. So please remember that this product thing works. The square root of a times b is equal to the square root of this. But the square root of a plus b is not the square root of a plus the square root of b. If you can remember that, you are way ahead. I hope this is helpful. I'm going to do one more video on this, I think. Your comments are always welcome. If you haven't already subscribed, please. Thanks.